Okay, Michaela is planning a trip in Ireland from Killary to Cork to visit Blarney Castle. She also wants to visit Mallow, which is located 39 kilometers due east of Killary and 22 kilometers due north of Cork. Draw the displacement vectors for the trip for the trip when she travels from Killary to Mallow to Cork. And then I'm going to answer these questions. What is the magnitude of her displacement when she reaches Cork? How much additional distance does Michaela travel in going to Cork by way of Mallow instead of going directly from Killary to Cork? And the second part of this problem is during Michaela's travel from Killary to Cork via Mallow, her travel time is 48 minutes. What is her average speed in meters per second? What is the magnitude of her average velocity in meters per second? So for the first part of the problem, I went ahead and drew a diagram of my displacement vectors, and so my vector 1 is going to be 39 kilometers. That's what they told me. That's from Killary to Mallow. Mallow to Cork was 22, and then this would be my displacement right here. So the magnitude of displacement is change in r equals square root of change in x squared plus change in y squared. And I plugged in what I knew, and that gave me 44.78 kilometers, which is, I just rounded to 45, but for this part I also used 44.78 to be more accurate. So additional distance traveled, I did vector r1 plus vector r2 minus vector r to get the additional distance traveled. And I plugged that in, and it gave me 16.22 kilometers. Let's see. All right, this is the second part of the problem. So it took her 48 minutes to get from Killary to Cork via Mallow. And, I didn't draw this one to scale like I did the other one with the protractor, but, you get the point. So this is all I did right here was I changed the kilometers to meters for R1 and R2, and then what else I did? Oh, total time traveled. I put 48 minutes and changed that to seconds, just conversions, and then for my average speed, I took my total distance traveled divided by my total time travel. Total travel time. And that gave me vector r1 plus vector r2 divided by t. And I plugged in what I knew, and it gave me 21.2 meters per second. And then for the second part of the problem, the magnitude of the total displacement. So I got vector, which is change in r equals square root of vector 1 squared plus vector r2 squared. And I plugged in what I knew, and it gave me 44,777.2 meters. And then to find the magnitude of average velocity, I took vector r divided by vector t, and that gave me 15.5 meters per second after I plugged in the magnitude of total displacement on top divided by the time in seconds. And that's my problem. I'm just going to show you, I'll just keep it like this, show you this problem just in case you want to read it. And you can pause the video. So, all right, let me know what you think.